So way back in grade 9, you talked about inequalities. So we're just going to go back. We're going to do a little bit of graphing, give you the definition, put it back into your head. Then we'll do the quadratic part. Yeah, I know. It's been a while. What's an inequality? A thing with things. Definitely has numbers, yes. It's like an equation. In fact, you did it right after you solved linear equations, then you did linear inequalities. Except they don't equal each other, they have a different symbol, and what might that symbol be?
Oh, is that the one where it's like no solution?
You're thinking systems, which is the second part of this unit, yes, but it's more about it doesn't have an equal sign, it has a less than, or a greater than, or a less than or equal to, or greater than or equal to. Like an equation, except there is no equal sign. I feel like that needs to be a semicolon. I don't really know when to use semicolons. I just put them when they kind of look like they should be there. There is a less than, greater than, less than or equal to, greater than or equal to. I don't know. That's why I don't teach English. Right there. I don't know. And I would ask Mr. McWilliam, but then he'd talk for a long time, so not so much. Have you ever had McWilliam? Have you ever had McWilliam? He talks a lot. A lot. Yes, yes, he does. And he's always ranting. He's always upset about something. And
Really? Are we likely going to get him in grade 11?
could, might.
Wait,
No, you could have Lewis, though. Could be either or.
I'm not doing IB English next year. No.
I think IB English would make my brain explode. I think I would rather go to the dentist. English and history, not my things. No.
History, it's fine. English, no. English is not my strong suit. There's no way I would crash and burn in IB.
So what we're going to do is go back again to grade 9, and we're going to look at just how to graph inequalities. And again, if you don't remember, no big deal, I'm going to review. So we're going to first look at how do you graph x is less than negative 3. Well, the difference from an inequality to an equation is the equation has one solution when it's linear, 0, 1, or 2 when it's quadratic. Inequalities have infinite solutions. So give me one number that is less than negative 3. Negative 9, negative 8 I heard. Give me another one. Negative 10, negative 6. Give me another one. How long could we keep playing this game? Forever. So the way we graph it is we're going to go to where negative 3 is, and we've got a choice between what's called an open dot or a closed dot, also sometimes called a black dot or a white dot. Not being racist at all, it's just what they're called. How do you know when you're using an open dot versus a closed dot or a black dot versus a white dot? Kind of. So these two would be open dots, and the other two would be closed dots. And that just means if the number is included or not. So we're going to do an open dot on 3. Now you can do it right on the number line. I'm going to do it above just so my arrow doesn't get mixed up with the number line arrow. You can do it right on top if you want to. And now we're just going to point in the direction. Where are the numbers that are less than negative 3? Are they to the left or to the right? That's how we graph an inequality. The way I like to remember, too, is the less than sign points the same way as the arrowhead. So when it's to the left, it makes like a little less than sign. In elementary, did you learn the alligator eats the bigger number? Yeah. I hate that. I wish they'd never teach you that. Because what happens when there's a variable? So how do you remember which is less than, which is greater than? Less than looks like an L. Greater than looks like not an L. Okay, like a tag on a G, or just less than looks like an L. So how would we graph this one? Well, we go to 4. We decide open dot or closed dot. Closed, why? Because it can include 4, and then we just have to point the arrow to the left or to the right? To the right. And again, the arrowhead matches the greater than symbol. Then you looked at crazy inequalities like this, like what? What does that even mean? So you've probably seen this notation before. And again, mathematicians, we love our notation. When you have less than or less than equal to, doesn't matter, and then a variable, then another less than, what English expression does that mean?
X is less than 2.
Yeah, but there's a shorter English word that means. In between. High five to Ethan. That's what we're saying in English. We're saying x is in between -2 and 5. It's a short way to say in between. So I don't need just one dot in this one, I need two. So I'm going to go to the -2 first, open dot or close dot. Why? Correct, because it's not or equal to -2. Then I'm going to go to 5, open dot or close dot. And how do I show in between? I just join them. That means all the numbers in between -2 and 5. Alex, you need to focus on this, please. Do number 4, or IV. Check with someone sitting around you. High five if you have the exact same picture. Yay. I heard three little high fives. Nice. That was a weak high five. That was a weak high five. Mitchell? No. I'm going to go to 3, open dot or close dot. I'm going to the 3 on the number line, not question number 3. Arrow to the left or arrow to the right? Who had the same picture? Oh, you can. You can make it as long as you want to make it. Or short. I mean, we wouldn't put the arrow here, but there's no real rule how far it goes. Do the last one. Oh, nice. Check with someone, high five. We just have some high five training. Nice. Where would you like me to put a dot? And what kind of dot would you like it to be? Where would you like me to put another dot? And what kind of dot would you like it to be? And how would you like me to draw the line? What does this mean?
It's in between all those.
All the numbers in between -7 and 1. Give me one possible answer.
0.
Yes, give me another one. Yes. Do they have to be whole numbers? 0.9. 9.5. No, 9.5. So negative 1.5.
Although obviously whole numbers we use the first one together.
0.99.
I enjoy repeating.
Yeah.
Very good. Does this you kind of remember this from grade 9?
Yeah.
Okay. Let's go to the new stuff.
I'm comfortable there. Yeah, that's a great try.
You did linear inequalities in grade 9. All we're doing now is quadratic.
Why is it even quadratic?
Because it's all what this year is about. Just like last year was all lines.
This is a legitimate question. I know it's like kind of getting out of hand, but what exactly do you use quadratics for?
Yeah, in
Like
real
what job?
life.
We just did 4 real-life applications. Who has to figure out height of a ball or height? Well, maybe you're not, but who does? So who would have to figure out height of an object that's being thrown?
What if physiotherapists do that?
Physicists Anybody designing sports equipment that has to throw, has to figure out the height of things? Golfers have to figure out the distance the ball's going to travel. What about profit questions? Who's going to use that? Business owners, right? All of economics. What about dimensions? Carpenters, architects, engineers, and what was the other kind of profit? Height. Numbers. Nobody uses numbers.
Unless you're mathematician.
Yeah.
Unless you never taught us how to do the McDonald's sign.
Oh, you just do two parabolas at the same time. Graph one, then graph another. Okay, after this? Okay. Yes, I am. Use the graph of y equals x squared minus 2x minus 3 to solve where x squared minus 2x minus 3 is greater than 0. So this is the part that's new. We're just adding in that little inequality. Okay, how do we graph a parabola?
Find the x-intercepts.
Those are two different methods. We can use either one you want. Which one would you like to use?
I'm good either way.
I would like to complete the square. Don't snarl at completing the square.
I like completing the square.
Alex, calc away, please.
Way more than I have.
Middle divided by 2 squared. Offer of 1. How do we balance? Now, this was an exact question on the test, and a lot of you forgot this minus 1. Alex, calculator away, please. I'm just writing down what she's saying. You might want to confirm it. Okay. What are the 3 pieces of information we need to graph a quadratic? Okay. Second piece of information? Okay. And the third piece of information? What do we graph first? Okay. Oh, I missed that point when I went to join it. Okay, left brains will understand how sad this makes me. I would too, but it's in felt pen. Left brains get it. Like, I'm very upset, but we'll move on.
Why do left brains get upset?
Because we like it to be perfect. We like it to be exact and perfect and pretty and.
I think we like that with writing.
I know.
Like, I don't know what it is.
So when we solved quadratics, which by the way, how many methods are there to solve a quadratic?
4.
They are?
Complete the square, factor, quadratic formula, and
Yes. That was when it was an equation. What we're dealing now with is an inequality, and we want to know all the points where this parabola is
Less than or
greater than 0. We want to know where are all the points where this parabola is greater than 0. Greater than 0 means above the x-axis. Less than would mean below. So the points where it's above would be all of these guys in here, because the arrow is going to keep going on and on and on and on. And it's also going to be all the points that are over here, because it keeps going on and on and on and on. Why not this section in between? Because the points there are below the x-axis. So when we're solving inequalities, that's what we're actually solving, is where are the points above when it's greater than, where are the points that are below when it's less than. So how do I say all of these points here? Well, if I think in terms of the x-intercept, what is its value? -1. And how do I say all these points that are the left of -1? X is less than or equal to -1. So let's talk about that. Why or equal to? because it's a black dot, right? It's an actual point on the parabola. Well, if I were to just draw this as a linear graph like we did the last one, if I'm pointing to the left, what does the symbol have to be up here? Less than. How do I say all these points up here? X is greater than or equal to 3. And that just comes from if I draw an arrow to the right like we did in grade 9, that's where I'm getting the value from. So what is the solution? It's both of these. It's all x's that are less than -1, all x's that are greater than 3. They're solving a quadratic inequality. That's with the graph. We're going to do it algebraically in a second.
We're doing that today.
Yeah, but it's okay. It's not that bad. I'm sorry. Okay, solve algebraically. Step number 1, solve as a quadratic equation. So not an inequality, just pretend there's an equal sign, solve it like we've solved a bajillion of these. How many ways are there to solve a quadratic? 4 methods. I told you I was going to say that a bajillion times this semester. And then next year, another bajillion times.
I should have kept a calendar. That would be fun.
I think you would have lost track by now. Now these next steps, you're going to be like, WTH, what is going on? Just go with me. When I show you the example, I'll explain them. But for now, you're going to be like, what? Put the solutions on a number line.
Just look up number lines if we're to do it in the book.
Honestly, I don't know because I don't use the book. So I don't know. You'll tell me when you start the homework. Even if I was a student, I couldn't use the book because it bothers me when you erase and it rips. I can't deal with that.
My papers are all.
Yeah, I can't deal with that. Okay, this you're going to be like, what is going on? Just relax. I'll show you when we do the first example. Choose a value in each interval. Choose a value in each interval and substitute into the inequality. Choose a value in each interval and substitute into the inequality. Decide if the answer is true or false. Highlight the true intervals.
So we're going to need a highlighter.
You can use a red pen, you can use a marker, use whatever. I'm just a highlighter. A highlighting person, yes. Last step, write the solutions. That's it.
Does Mr. Lockhart's class use the same booklet of notes? Yeah, you noticed.
Mr. Lockhart and Mr. Watt sometimes use all the time my stuff. Which is fine. I'm a sharer. That's fine.
That's like what Burnett did with
I might be the most organized person in the department. So I probably like have all the notes ready to go at the beginning of the unit, and sometimes they don't. So it's all good. It's all good. No, I just give them the electronic copies. I'm left-brained. It's not my fault. It was the way I was born. Makes it stand out, yeah. It's Highlights in the hair make the hair stand out. I don't know. But then there's low lights for your hair too, which is weird.
Well, unless you have blonde hair and you don't want blonde hair.
Yeah. But to a boy, they don't know what low lights and highlights are. They don't know.
I don't get like the frosted tip thing. That's just bad.
My boyfriend's into home repairs and he'll start talking and I have no idea, so I start talking makeup and hair. I have no idea.
What's the deal with the low lines? I never got that.
Never had highlights.
So step number 1 will be your favorite because we've done these a bajillion times. Step number 1 is just pretend it's a quadratic equation. But I threw one in,
We're allowed to do that?
just for step 1.
Can we do that on the test and do it?
Yes. Factor, quadratic formula, square root, complete the square.
Let's do. No, never mind. Factor.
No factory, please.
Factor is going to be your like
Factory is not my friend.
5 negative positive 5.
Agree to disagree.
Or negative 5 and positive 1.
There's the offer, looking for confirmation. What do we do after we factor?
Splits up.
Split and solve. So x equals, and x equals. Okay, so step 1 is straight up unit 3. Exactly what we did in unit 3, solve it. Step number 2, draw a number line. Now, we can put all the ticks, but again, mathematicians are pretty lazy people. So we typically just put 2 ticks, and then we just put the 2 values rather than doing a million ticks. Just make sure your lower number is on the left and your higher number is on the right. So I'm going to throw -1 here and 5 here. If you like to do all the ticks, that's fine. It's just we get kind of lazy.
I usually like to do one in the center.
Yeah, if you want 0 in the center, whatever, it doesn't matter. I'm going to switch colors. If you're a color person, you're going to want to switch with me. Step number 3 is going to happen at the same point because it's on the number line. What we've done here is we've created 3 intervals. There's an interval that's all the numbers less than -1. There's an interval that's between -1 and 5. And there's an interval where x is greater than 5. So we've got 3 different sections. All we need to do is pick any number we want in the 3 sections. So what I usually do is find where 0 will be because it's going to be the easiest number. And 0 in this case would be in the middle interval. Then we need 1 over here and 1 over here. I typically try to use 1. In this case, we can't because 1's in this interval and 1's over here. So the next easiest number is 10s and -10s. You can use any number you want. It just makes the calculation easier if it's 0, 1s, or 10s. So I'm going to pick -10 over here, and I'm going to pick +10 over there. Again, you can pick any number you want. It's just we got to do some mental math right now, so numbers are easier if they're 10s and 1s and 0s. Now, we don't have to show the work for this step. I'm just going to show it for the first example so you see what we're doing. I'm going back to the original question, and I'm going to sub in -10. So I'm saying -10 squared minus 4 times -10 minus 5 greater than 0. And so BEDMAS says exponents first, so -10 squared. And then I'm going to do the multiplication, -4 times -10. And then I've got that -5. And now just doing the addition, 100 plus 40 minus 5. And so that's why I tend to use 10s because they're easy to square and they're easy to multiply by something. And all I want to know is this true or false? Is 135 greater than 0? That is true. So I'm going to write a T above that interval. Okay, so this calculation you don't need to show. I'm just showing you for the first example what we're doing. Typically, we would do this in our head. Now I'm going to do the same thing with 0. So 0 squared minus 4 times 0 minus 5 greater than or equal to 0. Okay, so 0 squared, don't care so much about. -4 times 0, 0. So I end up with -5 less than, or sorry, greater than 0. -5 greater than 0. False. So I'm going to write a false. That's why I tend to start with 0, because it's the easiest one to do the mental math. You really just have to look at the equation and figure out it's minus 5. And now I'm going to do the same thing with 10. So 10 squared minus 4 times 10 minus 5 greater than 0.
So we have to do every solution.
Mhm.
Oh god.
Again, that's why I tend to use 10, because it's just easy numbers to calculate in your head. You can use any number you wanted. I could have used 7 here, but then I got to figure out 7 squared minus 4 times 7 minus 5. It's just harder numbers to calculate. That is step 3. I'm just going to bracket all of this because that's optional. We typically do it in our head and we don't have to show. If you're visual and you want to write it, write it. There's nothing wrong with that. It's just not necessary work.
Usually I like to write it first and reading those, and then maybe if it gets to a point where I feel like I need to.
Step number 4, I'm just going to highlight the true regions. This one happens to have 2. Now I just want you to look at that, and I want you to look at, I'll put them side by side, example number 1. Really what we've done is what the graph showed us. What we've done is figured out where are the intervals that are above. And that's what it happens to be. We know this is an up parabola, so if we had done this graphically, it would have come around here, and we've highlighted the up. All we need to do now is just write these answers. How do I express the numbers to the left of -1? X is less than -1. And this third interval is to the right of 5. X is greater than 5. Oh, sorry, less than -1. When do we put the or equal to? Well, it comes from the question. If the question has or equal to, the answer has or equal to. If the answer doesn't have or equal to, the question doesn't have or equal to. So you might just want to make a note it's not or equal to because the question didn't have it. Whew, there's solving a quadratic inequality. If it's not in the question, it's not in the answer. Okay, now do you want to know the shortcut?
Yes.
Now, when you get into calculus in grade 12, you're going to find out this is a big fat lie. But so for your world right now, these intervals will always flip-flop. If the first is true, the second will be, and the third will be. So the first pattern is TFT. So you don't actually need to calculate all 3. If you calculate 1, you know what the other ones are right away. Let's say we had calculated this one and it came out to be false. This would have been, and this would have been. Those are the only patterns you're going to see until calculus in grade 12 when I've lied to you. So that's why I said I don't actually do all this. What I do is I find the 0 because it's the easiest, and then I just figure out what the other 2 are, and I'll show you that in the next example. So that's why I bracketed this. We don't actually really do any of this work. Okay, let's do example 3. X squared minus 7x plus 12 less than equal to 0. How many ways to solve a quadratic? Which one would you like to use?
Complete the square.
Really, you're going to have to do 7 divided by 2 squared if you thought this through. You want to complete the square. Factor.
Well, to be fair, I read the animal.
Ooh, equals.
Animal, generally.
Am I boring you there? High five, Ethan. What do we do after we factor? Questions on step 1. Doesn't this seem easy now after unit 3 and unit 4? Okay, just make sure you're putting your numbers from smallest to greatest. Where is the interval where 0 is going to fall? Is it interval 1, interval 2, interval 3? I don't care about the other intervals. I really only care where 0 is because it's the easiest. And I like 0 because you don't have to do a lot of work up here. What's 0 squared? What's negative 7 times 0? So all you really need to look at is the constant. 12 less than or equal to 0. 12 is less than or equal to 0. So that has to be false. It has to be true. And the last one has to be false. Again, when you get into calculus, you'll get things that are false, true, true, and true, false, false, and all the other variations. That will not happen in your world until then. Okay, highlight the region that is true. You're always picking the one that is true. 5 is just getting the answer. Well, this comes from the graphing we did on the first page of the notes, is how do I say all the numbers between 3 and 4? What's the notation for between? So it starts with the smaller one, which is 3. Then it's always a less than x less than, that means between, and then the higher number, which is 4. All you need to decide now is it or greater than or not, or equal to? So does it have the or equal to or not have the or equal to? How do you know? Because it comes from the question. That's it. But this is the answer because there's a million different answers. No, and when we do the applications, I think then you'll see a situation where there isn't a defined answer. So for example, let's say, I don't know, thinking something really easy, you have $40. Give me all the different combinations you can spend with that. Well, you could spend $1, you could spend $6, you could spend $12.97. Is there one definitive thing you could buy? That's an inequality. As long as you haven't spent less than your 40, you're okay. How are we feeling so far? There's no exceptions. This is the steps every single time. Negative x squared plus 6x minus 5 greater than or equal to 0. Factor, quad formulas. Really? I kind of want a quad formula, at least one. No? Okay. Oh, what would you like to do? We're liking it so far? That was my question to you guys. What do you want to do with the negative? We need it, otherwise it wouldn't even be in the question, so we can't ignore it. Okay. Deal with it later, okay. That's always a good plan. How do you want to get rid of it? If we distribute, we're going to go right back to up here. Okay, let's split and solve and then see what we want to do. Well, mathematically what we would have done would be divide by -1 to get rid of it. Okay, which is fine if it's an equation, but what happens with an inequality when you divide by a negative? Yeah, so this is back from grade 9 when you solve linear equalities. Anytime you divide or multiply by a negative, you have to flip the sign. So what we're going to do is go back to the original question, and what we're going to do is divide everything by -1. What that does is cancel out the negative here. So we have our x squared, our minus 6x, our plus 5, which is what we factored. But now we just need to take the sign and flip it. So a greater than or equal to becomes less than or equal to. Why is that important, that flipping of the sign? Yes, it's where your true and false are going to be, will be backwards. Okay? So you might want to make a note is anytime you want to factor a negative, flip the inequality sign to get rid of it. Why do we have to flip the inequality sign? But why mathematically does it matter? So let's take any inequality. I don't know, let's say 6 is less than, make this a true inequality, 3. Okay? So mathematically, as long as I do one thing to one side of an inequality and do it to the other, I'm okay.
Wait, no, less than. No, 13.
We're happy now?
Yes.
Okay. So what I'm going to do is I'm going to multiply each side by -1, because as long as I do it to both sides, I'm allowed to do that. So if I multiply this by -1, what happens?
It's false.
It's now false. So to make it true, what do I need to do? Flip the sign. That's why inequalities work that way. What number comes first? And there's always going to be someone that puts them backwards. Always. Again, mathematically what we're doing is we're picking a number in every single interval and we're testing it, but for our sake, because it's easier, we're going to find where is 0.
In the middle, closer to 1.
Far left.
Left. No. Far left in between the...
But 0 would be less than 1. We're going to this new guy with the flip sign, so make sure you highlight him, you mark him, that you're not going back to the original here. Again, the beauty of the 0 is all we need to look at is the last number. 5 less than or equal to 0. False. True. False. What interval do we pick? True, always the true one. Or equal to or not or equal to? Why? Because it's in the question. But there's more to this question. What else does it say? And this freaked people out last year. What? What are you talking about? Well, this is just the very first page. So how do we graph this? Did you just scoff because you have to write 6 numbers? What kind of dot would you like at 1? What kind of dot would you like at 5? And then what would you like to do with them? Attach them. There is represent the solution on a number line. How's your tummies? Grumbly? How's your tummies?
I'm hungry.
I bet.
It's been 16 hours. No, that's wrong. So wrong.
Let's skip 6. It's Friday afternoon. It's 3:15. Let's just get through 5 and call it done.
Wait, where are we all happy? Are we doing it later or are we just practicing?
We'll do 5. We'll do now. We'll just forget about 6. It'll come up later in the unit. Yep, you're just a little bit step ahead of everyone. If we don't like this negative, because we know we're probably going to have to factor, we can get rid of it. How do we get rid of it? We divide by negative. And because it's an inequality, what's going to happen? So this is going to be 4x squared plus x minus 3 greater than 0. Factor could be the square, quad formula, square root.
Square root.
No, let's
Or
do
quad,
quad.
or quad formula.
Okay.
Formula. You said you wanted to do quad
I do want to do a quad formula.
At first I thought you said you wanted to do square root, but then I remembered you said quad formula. So, yeah.
X is equal to,
B plus or minus square root B or negative B.
what's B?
1.
What's A?
4.
What's C?
23.
What's A? How would you like to simplify? So I tend to do that and the multiplication and the bottom all in one step. One squared. 4 times 4 times 3. So again, don't feel you have to do it in order, whatever jumps out first. I see 4 times 3 because I know that's 12. And then I do 12 times 4.
48.
On the bottom, now what would you like to do? Not quite. We're not quite done yet. Yeah, we want to split these into the two answers. So negative 1, negative 7 over 8, negative 1 plus 7 over 8.
She's really tired and hungry.
Sadly, you were right, though. If you just kept going with that thought.
I don't know where it went. It drove off.
Negative 1, negative 7 is? Negative 8 divided by 8? Negative 1. Negative 1 plus 7? 6. 6 divided by 8. And if we reduce 6 over 8? 3/4, I think you might have said.
Yeah, 3/4.
And then people freak because it's a fraction. No, fractions are numbers. They're on the number line. We're okay with that. Which one's going to come first? Zero is in between. Just make sure you're going back to the one where we flip the sign, because that's what we solved from, not the original question.
Negative 3 is
It is wrong. So what do we put if it is wrong?
false.
You don't actually need to highlight it. It just we plugged it into this equation. So then we got negative 3 is greater than 0. And is that true or false? Negative 3 greater than 0. Negative 3 is not greater than 0. You don't actually need to highlight. It's just for visual people. How do we say these numbers over here on the left of negative 1?
X is less than
Or equal to or not or equal to? Why not?
because it's on the
And how do we say all these numbers here on the right of 3/4?
greater than
Or equal to? Not or equal to. That's as hard as it's going to get, by the way.